Solving trigonometric equations. Test trigonometric equations, and that is the solution for the last problem on your trigonometric equations test, right? Now here it is a very typical problem and interesting one, and here we will use compound angle formula, right? First step is whenever you get equations in cot and tan, write them in sine and cos. It becomes kind of simpler, right? So cot 2 theta could be written as cos 2 theta over sine 2 theta, right? Plus tan half theta can be written as sine half theta over cos of half theta, right? Equals to 0. Okay. Now we can take common denominator, and the common denominator for us is sine 2 theta cos half theta, and here we get cos 2 theta cos half theta plus sine 2 theta sine half theta equals to 0. Now we have something here in denominator, so the restriction is that sine 2 theta cannot be 0, nor can cos half theta be 0, right? So that is the restriction. Now if this has to be 0, that means numerator should be 0. So that implies cos 2 theta cos half theta plus sine 2 theta sine half theta should be 0. Now if you recall the formula for cos A minus cos B, it is cos A cos B plus sine A sine B, right? Therefore, we can write numerator as cos 2 theta minus half theta, right? So that is the full form of cos A cos B plus sine A sine B, right? Where A is 2 theta and half theta, right? Now that should be equal to 0, since numerator should be equal to 0 to give our answer, right? So what is that equal to? That is cos of, so 2 times 2 is 4, 4 minus 1 is 3. So cos of 3 theta by 2 equals to 0. That is what we get. So now, where is cos 0, right? So that is what we need to figure out. We know if we draw a graph for cos, so what do we get? We get a graph something like this, right? So cos is 0 at these points. But let's check our domain first before writing all the solutions, right? So our domain is actually theta is between 0 and 2 pi. How about 3 theta by 2? So our argument now is not theta, it is 3 theta by 2, right? So if theta is between 0 and 2 pi, how about 3 theta by 2? Let me multiply this by 3 theta by 2. Then we get that 0 is less than equals to 3 theta by 2. So we multiply by 3 by 2, right? It's less than equal to, if I multiply by 3 by 2, I get 3 pi, correct? Now, that means that we are looking for solutions which are between 0 to 3 pi. Do you understand what we are looking for? That means this is 2 pi and then this much. So that is actual domain for 3 pi by 2, correct? So these are all possible solutions which we are looking for. Therefore now we are looking for something like this. Let me draw it here again to show you. So what we have here is I'm just drawing a cosine wave here and then figuring out, so this one full circle is up to here, right? And then we got half of it till here. So this is what we are looking for. That is up to 3 pi, correct? This is 2 pi, from 0 to 2 pi. That is what it is for theta, right? I mean this angle x, let us say this angle is x, right? Now, which is 3 theta by 2. Now for this angle x, we are looking for a domain which is from 0 to 3 pi, not 2 pi, right? So this is 2 pi and 1 more. Do you see that? So that means if you do this, we have got how many zeros? We got 1, 2, and 3. 3 possible zeros, right? So all these 3 possible zeros will give us possible solutions. Do you get it? Now what are these zeros? So this value is, let's write down this value. This value is pi by 2 for us. So this is, oh, I'm writing 3, but it's pi by 2 for us. 2 pi by 2, which is pi. 3 pi by 2. 4 pi by 2 and 5 pi by 2, right? So these are the 3 possible solutions, okay? So if we plug this for 3 theta by 2, which is x, right? So we have solutions here as, let me draw a line here to write down the solutions on the right hand side. So the possible solutions for 3 theta by 2 are equals to pi by 2, 3 pi by 2, and 5 pi by 2. Since our domain for 3 theta by 2 is up to 3 pi, that is the thing which you need to understand. The domain changes when we have compound angles, correct? Now, from here we can solve for theta. What is theta equals to? So theta equals to, we'll multiply all by 2 over 3, right? So when you multiply by 2 over 3, this 2 gets cancelled and we get pi over 3 here. Now that 2 gets cancelled and we get 3 also gets cancelled, we get pi here. And in this case, we get 5 pi over 3, right? So these are still our solutions, right? But now let's look for the restrictions. Now, if you put pi over 3, is sine 2 theta 0? Because it cannot be. No, it is not 0. So that is okay. How about cos of half theta? That is also not 0, so that's fine. But for pi, if I put pi here, then what happens? Then cos half theta is 0. Do you see that? Therefore, this is not a solution, right? So this is cancelled since it falls under the restriction, right? So that one is not a solution. How about 5 pi by 3? Well, it passes the restrictions. It is not amongst the restrictions, correct? So therefore, final answer is theta equals to pi by 3 or 5 pi by 3. Correct? Do you get it? So that is the solution of this equation. So remember, a couple of things. First, the domain changes. Second, when you get your solutions, you have to test for restrictions and even otherwise, okay? So with that we end the test on trigonometric equations, and I hope by now we have covered up all what you wanted to know to solve trigonometric equations. You should do fairly well in your exam. All the best. Thank you.